Hello, welcome to Math Success Seminar Online. For now, I'm going to talk about prime numbers and prime factors. So what are prime numbers? What are prime factors? What does prime mean? Well, prime is like ultimate or lowest, or I guess think of like Optimus Prime or something, like he's the best. He's the optimal leader. So prime number is a number that can't be divided by anything except 1 and itself. So, for all intents and purposes of Math 910, 1 is not a prime number. Don't count 1. So what's the next number? 2. Actually, I'm going to do this in red. So 2 is a prime number, meaning every multiple of 2 is not prime, because 4 is 2 times 2, which is 2 prime numbers multiplied together. So 4 doesn't count. 6, 8. So notice all the even numbers are gone. Let me do this. Bam. Even, you're out of here. Gone, gone, gone. So what's the next prime number? Well, the next prime number is 3. Can 3 be divided by 2? No. Well, I mean, it can be, but you're not going to get an integer out of it. You would just have it as a fraction, that doesn't count either. Meaning every multiple of 3 is now going to be deleted. We already took care of 6, which means 9 is gone. Let's see, 15 is gone. What's next? 21 is gone. 27 is gone. 33 is gone, and 39 is gone. It's all scuffy here now. So that takes care of those. What's the next prime number? 5. 5 cannot be divided evenly by 3 or 2, so it's prime. Every multiple of 5 is not a prime number. We already took care of the 10s, they're gone, meaning anything that ends in a 5, that's also gone. So the next prime number, 7. 7 cannot be divided by 5, 3, or 2, and you're not going to get a number out of that, a nice round integer. So every multiple of 7 we have to delete. I think we already deleted them, because what, 14, 21, let's see, 21, 28 is gone, 35 is already gone. So yeah, we already took care of them. So actually, usually I have a chart that goes to 100, but I don't think I can fit 100 numbers on this little thing. So every number that remains is a prime number. What does prime mean in that case? It means any prime number before it, if you try to divide it, it's not going to work out. So you cannot divide 11 by 7, 5, 13, or 3 or 12. 2. Same with 13. Cannot be divided by 11, cannot be divided by 7, so forth. So all of these are not two numbers multiplied together. So what is an example of a composite number? Like 16 or 25, because 16 can be the result of two numbers being multiplied together. I know it's 4 times 4, and 4 is the result of two numbers being multiplied together. 2 and 2, 2 and 2. So this is called prime factorization, when you split a composite number into its pieces. So we could also write 16 as 2 times 2 times 2 times 2, and 2 is prime, so that's how we know to stop there. How about 25? Well, it's 5 times 5. Is 5 prime? Yes, so we stop. So if I were to write 25 in its prime factored form, it would be 5 times 5. Common, well, numbers that you're not normally used to seeing, but they are not prime numbers. 91. 91 is actually 13 times 7, which is 2 prime. 13 is prime, 7 is prime. So just watch out for 91 if 91 shows up. I like throwing 91 in there now that I know 91 is also non-prime. So what is a prime number? Well, there's only one even prime number, and it's 2. So chances are, if you're looking for primes, you're looking for the odd numbers, and then you want to try to divide one of these out of them. Typically, when you're prime factoring, for 9, 10 at least, they don't do prime factors above 20. Probably up to 13 maybe. I haven't seen any examples so far that go above. But those are prime numbers. And I briefly talked about prime factoring. Just to talk about prime factoring a little bit more. Let's see. 77, 202. So 77, you just want to think of what two numbers can I multiply together to get 77? Well, I know 7 is going to be one of them. And if we divide 7 out of this, we're going to get 11. So 77 in its factored form is 7 times 11. Very simple, very easy. This will become more important when you're multiplying and dividing fractions, because things that the numerator has in common with the denominator, they're going to cancel out. So if I were to write a problem like 77 over 11, I could just read this as division, but if I write it out in prime factors, we know 77 is 7 times 11, and we know 11 is just in the denominator by itself. So these 11s cancel each other out, and you're left with 7. Just to show quickly how that works. Now 202 is a bit of an annoying one. Why did I pick that one? Let's do 200. 200. So what two numbers can you multiply to make 200? Not sure. Well, let's start with the basics. Is it even? If it is even, you can always take a 2 out of it. 2 times what? 2 times 100. 100 is also even. 100 is 2 times what? 2 times 50. 50 is even. 2 and 25. 25 is not even, so now we got to get a little more clever. I know that this is a multiple of 5, which is 5 times 5. So writing 200 out in factored form is going to be 2, 2, 2, 5, 5. So 2 times 2 times 2 times 5 times 5. And this is called the factor tree. There's more techniques for factoring, but I like the factor tree because you can, once you reach a prime number, all you got to do is, all right, I gotta include that here. I gotta include this there. I gotta include this there, you know. So prime numbers, prime factors, very important when you're dealing with fractions especially, because you want to reduce fractions to the lowest term. I'm going to talk about that a bit more. That's all I have to say, I guess, right now about prime numbers. They're going to show up later on, so I'm sure there's going to be more material on them. But thanks for watching, and hopefully this serves as a good reference video for prime numbers and what prime factors are. And I'll catch you next time.